Welcome to Introduction to Data Science. So this is the first lecture for Introduction to the Data Science course. Okay, at the end of this lecture, the student should explain the concept of data science and data science pipeline. The contents of this lecture are Introduction to Data Science applications, data science pipeline, and business understanding. So what is data science? Data science actually is a combination of different uh, area such as different fields such as mathematics, computer science, statistics. So actually it's a blend of various tools, algorithm, and machine learning principles with the goal of discover hidden pattern from the raw data. So we understand that there is a raw data. We have to use the blends of tools and applications to predict, discover the hidden pattern of our data. Data science is primarily used to make decision and predictions, making use of analytics, prescriptive analytics, which are the combination of predictive analysis and decision making, and machine learning. We use machine learning for that. Data scientist not only does the exploratory analysis to discover insights from it, but also uses various advanced machine learning algorithms to identify the occurrence of the particular event in the future. A data scientist will look at the data from many angles by processing history of the data. So, as we said, data science is the interdisciplinary or multidisciplinary fields combination of aspects of combines aspects of computer science, statistics, and domain expertise. Data-driven insights focus on extracting meaningful insights and patterns from the large set of structured and unstructured data. So it's make a pattern from our data. Okay, it's used for problem solving. It utilize data analysis, machine learning, and predictive modeling to solve complex problems. So it's a combination of tools and techniques involve the use of tools such as Python, R, SQL, and libraries like TensorFlow and Scikit-learn from Python. We can use it in Python. It's used for decision making. It helps in making data-informed decision across various industries, such as finance, healthcare, manufacturing. It's continuous process from data collection and cleaning the data, visualization, and interpretation. So we have different type of analysis of the data. Predictive analytics is a branch of data science that uses statistical techniques, machine learning algorithms, and historical data to make prediction about the future event or the trend. So in the predictive, we use these tools such as machine learning algorithms, historical of the data, statistical techniques to predict the future event. So we have to use the model to train our machine learning. The machine learning will understand the pattern and can predict the future. It helps in forecasting outcomes based on the patterns detected in the data. If you want a model that can predict the possibilities of the particular event in the future, you can apply predictive analytics. For instance, predictive maintenance is a crucial in industry like manufacturing, aviation and energy. By analyzing historic data and the sensor information, we can predict the failures of the equipment. For instance, imagine that you work in the industry, in the manufacturing line. In the manufacturing line, actually, is continuous work. Maybe some companies for 24 hours continuously they have to the assembly line should work. They cannot sleep the line because of the failure. So, if uh, we um, we are the engineer of that company, we can use the analytics, predictive analytics and machine learning to through by making a pattern of the previous historic data of the maintenance. For example, how often uh, the machine go to fail actually. So another is uh, prescriptive data analytics, which is combination of machine learning and decision making. Is more advanced branch of the data analytics that not only predict future outcome but also provides recommendation for the action to achieve desired results. It combines data analysis with optimization and decision making algorithms to suggest the best course of the action based on the predictive insights. If you want a model that has the intelligence of taking it on its own decision and the ability to modify it with dynamic parameters, you certainly need prescriptive analytics. For example, uh, production schedule optimization. Predictive analysis can help manufacturers optimize production schedule. Okay, they want to optimize the production schedule to have better and more efficient performance by considering factors like machine availability, resources, containers, and demand fluctuation. Okay, it can recommend the most efficient. It can be used. This data analytics can be used to recommend the most efficient production sequence to maximize throughput while minimizing downtime and resource usage. Descriptive analytics. Descriptive analytics in engineering involves the use of data analysis techniques to summarize and predict historical data in a clear and meaningful way. This type of analytics helps engineers and decision makers gain the insight from the past event and the trend. Is look at to the past event, okay, and figure out and make the decision. For instance, descriptive analytics can be applied to analyze past failures and indicates in engineering systems. By examining historical data on the equipment breakdown or structural failure, engineers can identify the pattern and root causes which can inform future maintenance and design improvement. Diagno- Diagnostic analytics focus on understanding why certain events or trends happen by um, delving deeper into the data to identify the causes behind it. So if we want to the reason why something happened, we need this analysis. It helps in uncovering relation between variables and understanding the factors that contributed to the particular outcome. So we have bunch of data. We can understand the relation between the variables. Okay, for example, in manufacturing, safety indicates are a concern. Diagnostic analytics can help investigate accidents and near miss incidents by analyzing historical safety data and identifying contribution factors. So we can use the machine learning for predicting a trend and for making prediction. So it can understand the trend and make of the data and make the prediction. If you have transactional data of the finance of company and need to build a model to determine the future trend, then machine learning algorithms are the best bet. Okay. For example, the fraud detection. So you have a company, you want to understand the fraud detection. If any abnormalities in the trend of the finance of the company, and the machine learning can understand and help us to detect the fraud using the historical record. So machine learning can be used also in discovering the pattern. So if you don't have the parameters based on which you can make prediction, then you need to find the hidden patterns within the data set to be able to make meaningful prediction. For instance, let's say you are working on the telephone company and you need to establish a network by putting towers in a region. Then you can use the clustering technique to find those towers. So we want to find the best location for the network tower. So we can use machine learning to understand the patterns and recognize the best region to apply the tower. So why data science? Example, how data science is being used in the various domain. So if you could understand the precise requirements of your customers from the existing data, like customers past browsing history, purchase history, age and income. With the vast amount of the variety of data, you can train model more efficiently and recommend the product to the customer with more precision. For instance, if the advertise that you see in the Google, in your Gmail, or in the YouTube is based. It used your data browsing history, okay, to recommend you the best product that suits to you. Okay, they use data science for that. It's one of the example. So another example is self-driving cars. The self-driving cars collect the live data from the sensors. So the autonomous cars use the sense data from lidar, from the camera, in 3D or 2D, from GPS or from satellites, the traffic of the satellites, that understand the best path and to the destination. So for example, it's going to from A to B. From the lidar can understand the obstacle, for example. So this data should be collected and analyzed by the AI applications. So for example, it can be used for weather forecasting. Data from the ships, aircraft, radar, satellite can be collected and analyzed to build a model. So we can use the data science to predict the forecasting. So it can be avoid the catastrophic damages of the harsh weather, for example. From this data science, we can understand the pattern of the weather and use through data science. So you can see the different example can be used in automation, social media, marketing, healthcare, insurance, credit and insurance in the sales, in the traveling industry. So data sciences are actually used in different industries. So who is data science? In order to uncover useful intelligence for the organization, data science must master the full spectrum of the data science life cycle and process a level of flexibility and understanding to maximize return at each phases of the process. So a data scientist should be able to identify relevant questions, collect data from uh, multitude of different data sources. It can be he or she should be able to organize the information, translate result to the solution, communicate their finding in a way that positively affects business decision. So the ability to take data, to be able to understand it, to process it, to ex- extract value from it, to visualize it, to communicate it. It's said by Hal Varian, the chief economist at the Google. So a data science should be able to understand the data, to process, okay, extract the value, visualize, and communicate with the data. So the rule of the data scientist. Data scientists are the well-rounded, data-driven individual with a high-level technical skill, capable of building complex quantitative algorithms to organize and synthesize large amount of information use. So, experience in communication and leadership, he should be able to process a strong quantitative background in statistics and linear algebra. So, it should have the different knowledge of statistics, mathematics, linear algebra, and as well as programming knowledge. So, there are some tools that the data science uh, could be could use them like R, Python, D3, GitHub. We can see it in this table. So it is the pipeline for the data science. So a raw data goes through there are three stages that the process of the raw data to operation. So raw data goes through the data engineering, machine learning, and finally operations. So in the data engineering, we have data rendering, data cleaning, and data preparation. So we prepare our data. This data will be feed, the prepared data will be feed to the machine learning. Better prepared data we have, more accurate prediction we will have from machine learning. Better prediction we have, better decision making we will have for our company or any places that we will to use it. Okay. Okay. First one is the data engineering. Okay. The first process is data engineering. Data and combines includes the data rendering, data cleaning, and data preparation. Data rendering is a process of manipulating raw data to make it useful for data analytic or to train a machine learning. So it's a process of cleaning our data. So we need to clean our data. In this process of the messy data, infected data, with a many numbers common issue, including the missing value, bad or incorrect delimiters, inconsistent records, or insufficient parameters will be deleted. The data should be prepared for the next stage, which is machine learning. Machine learning is a process of the machine learning algorithm that data will be trained and used for making a pattern and predict the data. Model validation is a process of validate the trained data. So how much our trained data is reliable to going for decision making. So in operation, model is divided to two sections: the model deployment and model visualization. Model deployment is the process of deploying the model into some production environment to apply to a new data. Okay. Data visualization provides the means of the products a data that answers some question about the original data. So this is another. There is another operations of data science, which is data life cycle. This data life cycle and data pipeline are actually a mirror to each other. So they cover this data science life cycle cover the process of pipeline. So they have 7 phases like business understanding, data mining, data cleaning, data exploration, feature engineering, predictive modeling, and data visualization. So a data science life cycle is an iterative set of steps. It's iterative. You take to deliver a data science project or product. For most phases in the life cycle, the movement can be either forward or backward. Okay. So first phase is business understanding or identifying our problem. So we have to specify the key variables for business understanding and related metrics to be used as the model target and determine the success of the project. So in this stage, in the first stage, you should understand what are you expected to do, and when your project is done, what's the parameters of being success. So how we can understand that we are done, to identify the relevant data sources that the business has access or need to be obtained. So we have to understand the process and identify the problem, and we have to understand which business we are dealing. So what we need to be done in the business understanding phase. You have to understand the business problem, define the frame the business problem, state clearly the problem to be solved and why, formulate questions that define the business goals that the data science techniques can be target. We understand the question, how much or how many, okay, regression, which category, which group we are facing. They have to understand the category of the data. Okay, is there any abnormalities in our data? Which option should be taken? The recommendation. Okay, so we will have the general view of our data. So what we need to be done in the identify the. So we have to identify the key business variables that the analysis needs to be predict. Identify the project risks, including ethical consideration. Define success metrics. The metrics must be SMART. SMART, S for specific, M for measurable, A for attainable, re for relevant, and T for time base. Okay. We can identify the key stakeholders. Okay, who we are dealing, which company is our employer actually, align with the stakeholders with the data science team. So we have to deal with our boss actually. Okay, access to the resources. So we have to identify our resources, what resources we will have. Okay, and develop and communicate a high level flexible project plan. So we have to understand our project plan. Okay, thank you for watching this video. uh, Lecture 1 has been done. Thank you.